name's Philip Kramp. I'm the solution architect, so we'll start things off with some slides, some questions, and then we'll go into a demo and kind of show you in my little lab environment kind of what it actually looks like, and we can click around and poke at it a little bit. So I think the first thing we have a poll for you guys just to kind of set the stage, and it's basically what is your familiarity with Rancher Government? So if you want to put up that first poll. Let us know if you're familiar with our company. First thing, who we are, for those that are either a little unfamiliar or completely unfamiliar with us. So this is just a lot of text basically to say that we are a government solutions group that is designed just to meet U.S. government and military needs. And this is showing basically breaking it down into little pictures so it's a little more friendly to look at. Basically, we're owned by SUSE, which is a German company that has made SUSE Linux. They've acquired Rancher, Kubernetes, RK2, K3S, and basically we have then gone through the FOCI mitigation process to firewall us off because they are a foreign-owned company so that we can do business with the US government. So there's all kinds of rules and procedures in place to kind of separate us. But the nice thing is that means we do have some global support and additional resources to help with engineering when we need, but we are focused on the specific needs of the US government so that, for example, when something comes up, for example, a new version of FIPS or something else, we're very familiar with it and we can focus on that, get those changes implemented and put in quickly so that we can meet everyone's needs and goals and get everything up and running as rapidly as possible. Basically, same as pretty much any open source software, the primary benefits of having a subscription are support. We also go through the certification processes so you can meet those ATO packages, keep your security folks happy. We also backport and do the extended lifecycle. So if you, for example, if you wanted to use upstream open source Kubernetes or upstream open source RK2, Harvester, or whatever it may be, in order to get those latest security patches, features, etc., you kind of have to keep rapidly implementing. And frequently for production, especially for disconnected installations, which may have, for example, classified networks, you can't really keep up with that pace. And so we make sure that we have an extended life cycle, we backport those fixes, and we get them going and keep supporting you so that you can roll on a more leisurely pace, but still be secure. We also have consulting services. So if you need some hands-on help and assistance, we can do that. And we can have people that can help you out. And then we've got basically the Carbide, which we'll get into shortly. So we take those upstream versions and we kind of harden them and make them more suitable for those government customers. Basically just a checkbox kind of going through some of what we just talked about. So some of the things we provide with that Carbide is we provide some signatures, verify that the images, SBOMs, vulnerability reports are all there. We have a secure portal, so you can validate that it does in fact come from us, that it hasn't been tampered with. We, as I mentioned, we go through the FIPS process, we go through the DISA STIGs, and for example, with the government harvester, which we're going to be showing here today, that comes pre-hardened for you. So when you go ahead and install harvester for government versus commercial harvester or open source harvester, it has FIPS, it has the STIG already applied and already there so that you don't have to then harden it after the fact. So as I mentioned, we're going through the DISA STIGs. We have some already in place. Rancher RK2. Harvester is currently in progress. So we've been going back and forth with DISA, finalizing that STIG. But the controls that we have gone through DISA with, or gone through with DISA, are already in place when you install that government harvester. So using that, you'll have it hardened nice out of the box. And then, as I mentioned, we had the Carbide and everything there for you. We have basically all these open source projects that we use and contribute back to. And then when you come and get it from us, so you get support, you get the capabilities. The RGS products may have slightly different names. So Rancher is RGS Manager is the same thing. We've got Harvester RGS HCI, so that's primarily what we'll be focusing on today. But then there's some other security tools as well, storage, things like that. So basically, this is just kind of mapping what those things become when they go from that open source project into a supported product. We do have a question. So the The harvester STIG, is that referring to regular open source harvester having a STIG? So there will be a STIG that will apply to anything. However, the government harvester is the one that will come with it already applied when you do that install. Hopefully that answers your question. That is in progress, and hopefully we will have a version we can publish here shortly. But that comes down to distance timelines and how quickly they go through their process. As I mentioned, so let's say you decide Harvester is something that you're interested in, you want to do it, but you need some help getting off the ground. We do have training, we have consulting, as well as premium services, so we can give you the training you may need or extra bodies you may need to help get things up off the ground, get you running, and have everything going more quickly so that you can get that ROI more rapidly instead of you can figure it all out, you can get it up and running, but getting things running quickly and making sure they're configured well, especially for a production type environment, you may want some additional help, and we have that available as well. Let's do the second poll for focusing on basically where are you basically using that virtualization. Are you currently using it in data centers? Are you looking at doing it at the edge or a combination of those things? And of course, the edge can have a lot of different meanings. It can be everything from a NUC to a ruggedized case with a whole bunch of servers or a portable trailer. And that just kind of comes across depending on what that actual use case is. So frequently you need to kind of dig into what do people mean by edge. As I mentioned, so we've got a number of different tools that are open source projects that we then productize to support and give that long-term accreditation and compatibility. So we've got security, stack state, the infrastructure piece, our RGS HCI or Harvester Government. And so one of the things we also want to do is we try not to do any lock-in or force you to use a particular tool. So we've got our Rancher Manager or RGS Manager. And yes, of course, we'd like you to use our Kubernetes, which is RK2 or K3S, but you don't have to. So you can use that same Rancher Manager, whether it's to manage AWS, EKS, if you want to manage Azure, Google, any other Kubernetes platform, and also for managing your Harvester platform if you're doing on-prem Harvester installations. You can use that same manager as long as there's interconnectivity and network connectivity in between those locations. You can have that one pane of glass to let you see everything that's going on in your environment. And then you can use those RBAC controls to limit who has access to what, both from a visibility as well as editing, so that you can make sure that people are well connected and those that need to see overall visibility into resources utilization status can do so from that nice single pane of glass. As I mentioned, you can use that Rancher with our products, with third-party ones as well. Same with the underlying Linux distribution. So you can use SUSEs, but you can also use Ubuntu, AWS Linux, Red Hat Linux, whatever you may need. And same with the underlying infrastructure. So you can use it on VMware, you can use it on Amazon, you can use it bare metal. Primarily today, we're going to be focusing on setting up our own bare metal instances and using Harvester for that. But you have lots of options to use the other tools that are out there. We have a number of certified integrations. This is just a subset. So we have a lot of different partners that we work with. We work with them to ensure that their products work well for our customers. We have communications where we can work with them on any issues and troubleshooting. For example, with VDI, so virtual desktops, virtual applications, we have a partnership with Chasm where they can deploy their application. It runs on Kubernetes, it runs on our Harvester implementation. And then you can provide your users with virtual desktops. You can provide them with just applications as well. So maybe they need a whole desktop, but maybe they just need Visual Studio Code or just Chrome or something. And so you can kind of slim those images down and share out just a subset of them, both to save on storage as well as network bandwidth and still getting users what they need. We do work with a number of agencies that I mentioned. RGS is the FOCI mitigated subsidiary of SUSE. We only work with basically the federal government and their agencies. And these are just a subset of the ones that we are currently in. We have ATOs for products in production with many of these agencies, just to kind of show where we are. All right. If you want to do poll 3, so familiarity with Harvester virtualization. So this is the part that we're about to dive into and spend basically the rest of this time talking about is Harvester. Harvester virtualization or RGS HCI, our basically going to be the focus of this. So this is just kind of to gauge where people are, so we can kind of gauge what people's questions are may be. Basically, where we are today. Enterprises are aggressively adopting containers. There are still a lot of places where containers haven't started, but most places have at least heard of containers and considering what they may do with their next implementations. So you've got cloud native capabilities where they can do auto scaling, healing, allow you to deploy across multiple environments, and allow you to deploy multiple places. So whether that's public clouds, data centers, or edge, you can kind of do that consistent deployment across all those solutions and makes it easier to manage as well as to troubleshoot and maintain. One of the problems with the edge is connectivity. So how do you get things there? What happens when you lose that connectivity? You have increased latency, things like that. So frequently, of course, you can't connect back to the cloud or a stateside data center. So you may have something like this picture on the lower right. That particular box is a carry-on sized, basically suitcase with three servers, each with 112 cores processing and 128 gigs of RAM each. So you could basically have a lot of compute in a carry-on sized case, and that would allow you to kind of get this compute out to the edge and then minimize the amount of either network or reach back you need to those other stateside resources. So, all right. So we have cloud native virtualization. So this allows you to integrate your VMs and your containers. So as I mentioned, a lot of places are going towards containers, but not everyone's there, and some things may not be able to go there at all. You may have some legacy applications, nobody's currently developing them, but you still have to maintain them, or that you're basically just keeping the lights on doing patches, but not making underlying source code changes. So those things are likely going to be VMs forever, or at least until the next iteration. And so you need a way to be able to run your VMs and your containers side by side. And so that's where our Harvester component comes in. So it uses that Kubernetes orchestration piece. It's meant for dynamic scalable environments, but allows you to use some of those more modern techniques for doing their orchestration, your load management, and moving things around as needed. By using that same common interface for both VMs and containers, you can kind of simplify everything for your users as well as your admins. Harvester is a basically a hypervisor for running your legacy workloads, or if you need new VMs as well, you can do that. Like I mentioned, Chasm. So let's say you need to share VDI with your users. That's a great use case for that. And it uses the KVM as the underlying technology. So KVM is the same technology that underlines, like, for example, EC2, as well as many of the other hypervisors today. And the way that gets tied into Kubernetes is a project called KubeVirt, which enables you to basically run VMs as very large containers in a Kubernetes type environment. We have another question. The same trend of moving towards containers. Has RGS looked into integrating bootc into Harvester? I believe so, but we'll have to get back to you after the webinar with an exact answer, unless one of our guys is able to find an answer while I go through the presentation. We'll try to find that, but if not, we can get you an answer after the place. But I believe that is on the roadmap. I'm just not sure what the time frame is. So basically, we want to take this bare metal platform for Rancher and your container workloads and give you that nice cloud native HCI. So what we want to be able to do is give you those cloud native capabilities and allow you to scale it out flexible and kind of do that infrastructure as code. So that way things are repeatable. It doesn't matter who implements it. It happens the same way every time. And so much like containers, you can define your virtual machines via YAML and basically kind of script them out so that they're prescriptive and say, hey, this is the formula for my VM. Make a new one of these or make 10 of these or whatever it is you may need. As we mentioned, Harvester is the open source project. It is 100% open source. We do some additional things when we do the government version, making sure that it has those hardenings already applied. But it is an open source project, and the same underlying code is there basically. One of the things we want to make sure that it is as simple as possible. So the install, basically we give you an ISO. For your first install, what you're going to do is basically run through that little text-based interface, install everything. But as you get more comfortable, or maybe you want to scale this thing out, you can basically configure all that just like with the containers and with the VMs as a configuration file. And then you can go ahead and deploy these things in an automated fashion. Say, all right, boot up this ISO and deploy these configurations, give it this host name, this IP address, and whatever other settings you need to give it, and boot things up automatically. One of the things we also do is we're not prescriptive on it has to have exactly this certified Dell appliance or this HPE server. We basically give you recommendations for minimum network speed. So for production, we recommend 10 gig networks for maintaining the storage throughput that you may need. And we recommend that you have so much CPU and so much RAM. And then you can deploy this either as a single node or three or more nodes. And the reason for that is for the three or more is Kubernetes uses something called etcd, which is the state of the cluster. And that state of the cluster has the three witnesses. And the reason for that is so that if there's ever an disagreement, you can't have a tie. So with one, of course, there's no one to have a tie with, or with three, there's no one to have, you can't have a tie because you'll have two that agree. And so that's why you can do one or three and above nodes for these clusters. As I mentioned, what we want to do is enable users to be able to run containers and VMs side by side. And so that's what we're going to do here. And we're not going to make you use specific hardware for that requirement. Here's kind of just a sample architecture. As I mentioned, basically 3 is good so that you have that etcd. So that's why we usually use 3 as the recommendation. And then you can use nodes 4, 5, 6, 7, whatever it may be, and not have some of those overhead administrative functions running. So you get a little bit more compute and RAM out of it because you don't have those extra capabilities running. We use open source project called Multus for doing all the networking and management. KubeVirt, as I mentioned, is the project that allows you to run KVM in a container. That's the project for doing that capability. It's also used by a bunch of other companies. One of the cool things, I think it was last year, or maybe even the year before at this point, NVIDIA uses KubeVirt for their NVIDIA Go cloud gaming platform. And so as a result, of course, the gamers and everything don't want their performance to degrade. They want a consistent experience. So NVIDIA spent a lot of time writing a bunch of test cases for the KubeVirt project. And now anytime source code is contributed back to that project, it has to run through these test cases to ensure that the performance of the VMs doesn't degrade. And so that it has to stay at the same level or improve. And those test cases that NVIDIA wrote help to ensure that that is the case. Longhorn is our storage component. So it's kind of similar to vSAN for VMware. It allows you to use those local disks, and then it's going to want to create 3 copies of them across your various nodes so that you have that resiliency and redundancy of the data. And I mentioned RK2 is our Kubernetes version, so it is running that for doing the Kubernetes component. And then one of the things as well, so I mentioned earlier, for the most part, we're not prescriptive and let you run whatever Linux you want. Harvester, because it is a hyperconverged infrastructure, has that operating system built in. It is also, in order to give you the best performance with the least overhead, it is a slimmed down version of SUSE SLE Micro. And so it is purpose built for running Kubernetes. It is also semi-immutable. So a lot of changes, for example, SSH config, things like that cannot be done while the server is up and running. So that is both for security as well for as making it a little bit lighter. So that's why for Harvester, your operating system is going to come bundled in. It's already going to be locked down. And that's also the reason why Harvester Government makes things quite a bit easier for you because those security settings are already applied and you don't have to go through and try to make the config changes that are necessary for that SLE microenvironment to get booted up and then apply the FIPS, apply the STIG, and get locked back down after the fact. As I mentioned, Harvester Government is the version that basically we sell support for and we provide our customers. One of the things it does go through our RGS software factory, so it is compiled and built on US soil. So you get that ISO from us. It was compiled here. You get the signature and everything, so you can validate that it did in fact come from us and not from some random third party. As I mentioned, it is hardened out of the box. We also have automated pipelines for doing the build and test. so that we can get those new versions out to you quickly from a new open source version to a new government harvester version. We have used our capabilities, as I mentioned, we focus just on those government customers. So for example, we've had requirements come in for harvester particularly, where one of our Air Force customers needed a specific requirement that in order to use a hypervisor in the event of a power outage or failure, not of the underlying hard drive, but the power basically, you could power it back on and it would come back up on its own and be ready for users to use it without user input and within a certain time window. It did take a little bit longer initially, but we worked with them to make sure we met that requirement and got that added back into the Harvester product, and is now available there for everyone so that within that time period it can boot up on its own and come back up from the a power outage without data loss or manual intervention required. We do have our own engineers and testing in-house, as well as our support team. So our support team, sometimes when you buy these products, you do have to pay additionally, for example, for confirmed stateside support. However, because RGS is a FOCI mitigated company, all of our resources and everything are US based already. So there's no additional fee or anything extra that you have to do. All of our support is US based support. Obviously, VMware is the giant elephant in the room. They've been around for years. So one of the things that they have that just nobody else is going to have it yet, it is rapidly growing, is the long and huge partner relationships with a lot of these things. So for example, for backup and restore, there's currently, I believe, 4 or 5 big companies that do backup and restore for Kubernetes and for Harvester. So you got Cast and Veeam, you've got Trilio, you've got Commvault, Cloud Casa, and I think one or two more. Whereas for VMware, you have probably 50, 100 different options that you could buy backups from. So you don't quite have as huge of a portfolio, but it is rapidly growing constantly. I believe 2, 3 years ago, there were only two, and now we're at 5 or 6 commercial products that do backup and support. One of the things we try to do is make sure that we don't lock you into particular hardware. So as I mentioned, there's no special requirements. You don't have to have a particular Dell. You don't have to have a particular version of Dell. You can use the hardware that you already have as long as it meets those minimum spec requirements. So this allows you to kind of reuse a lot of those legacy systems where the servers and everything work perfectly fine, but they may not meet the latest requirements for example, for the latest VMware or some other piece of software that has very specific hardware requirements. We do use well-defined and standardized APIs. That way like I mentioned, we try not to do any vendor lock-in. So we use standard Kubernetes APIs, standard KubeVirt APIs, so that if you make these calls on our software and at some point you either have another vendor software piece, you can still reuse all that work you did to make sure it can come up and running on our software stack. We do that by maintaining our open standards focus and making sure we don't make proprietary tools that only work on our software. As I mentioned, Harvester is Kubernetes. It basically takes all those Kubernetes components, which does all your scheduling, your orchestration. One of the things that you do with containers is you can say, hey, I want one of these to run at all times, for example, or I want 2 or 3, and it can go ahead and do basically apply those same capabilities to your virtual machines as well. It allows your services to run bare metal. We do have monitoring observability tools. We have security tools. You may have heard of NuVector that can tie in and monitor your stack and make sure that it's staying in compliance and keeping things up and running. Obviously, if you're doing a single node, you're not going to have any failover or HA. Outside of that, we do have failover and HA. You can do live migration. You can run things over. So let's say either a node fails or it needs to have some maintenance. It can go ahead and move those workloads over to another machine. You can also manually kick off a migration or do it via an API call if you know, for example, a particular node needs to go down. One of the other things you can do as well, you can use basically labels to say, hey, this VM needs GPUs, for example. So you can do GPU pass-through. And then it's only going to be able to migrate those to other nodes that have those GPUs as well, so that it makes sure it's intelligent about that migration and it doesn't move things to places that don't have the underlying resources it needs. One of the nice things as well is we do have ARM64 support. So that box I showed earlier, that was a suitcase-sized box. Those were ARM cores that were in there. The nice thing about that is ARM uses about a quarter of the power of AMD. So you can either have 4 times as much compute in the same space as you would with an Intel-based system or x86 system for the same power requirements, or basically you could use a quarter of the power to run an equivalent CPU stack with ARM. So of course, not everything today quite supports ARM yet, but more stuff is being added all the time. So that can come in handy for certain customers. As I mentioned, we try not to lock anything in. We try to keep things open and not lock you in. As we are focused on government customers, we are very aware of edge air-gapped environments. So we have a tool called Hauler, which we developed that is an open source project as well, that allows you to basically copy the bits that you need from the cloud to either a disk or to another machine. And then you can stand them up on the far end once you sneaker net that over to the other environment or push it through a cross-domain solution or something. Basically get those bits to the other side. We have documentation as well as tools to help you migrate and deal with those hurdles. As I mentioned, we do as well help. Once you're familiar with the environment, you can do basically push button deployments. So you can basically script what your environment looks like and basically deploy your entire harvester stack. And one of the things that's coming later this year, the ability to basically populate that stack once it's stood up. So you can say, all right, give me a harvester stack with these 3 nodes, with these domain names and these IP addresses. But then you can say also go ahead and deploy these VMs to it, deploy these Helm charts, and basically script out and deploying this entire stack so that you can give it to somebody in the event of a disaster, or if you need to ship it over to another location, they need to recover it, and they don't necessarily have the administrative expertise or the integration knowledge. They can go ahead and easily do that without needing all that extra training and support that they would otherwise have to do if they're having to stand it up from scratch themselves. We do have our secure software supply chain, so that's what all of our pieces of software go through for that Carbide portal to ensure that there is no exceptions or anything, any vulnerabilities in there that we don't know about before they get pushed out to customers. One of the examples here is kind of what that stack could look like. So what we want to do basically is decouple that application from the underlying hardware so that you can swap out the hardware based on what that mission is. So you can see we have a couple examples. We've got a single node one up here. We've got this one maybe back at a data center that's got 4 servers, and then this edge-based one which only has 3. And regardless of which platform it is, you can use the same automation, you can use the same capabilities, and go ahead and deploy that out across the various environments, whatever it may need. And you can do GPU pass-through, you can do PCI pass-through. So if there's particular sensors or radios that your application needs, you can pass those through to the underlying virtual machines or containers. As I mentioned, what we try to make sure you can do is you can do everything with GitOps. You can do infrastructure as code. This enables you to do those push button deployments, enables you to kind of automate and rapidly deploy these things. And the other advantage too is that makes it repeatable and doesn't matter who does it at which location. If everyone's following the same set of playbooks, the same set of automation, it's going to look the same once the platform comes up. One of the things is scaling out. How do we scale out to those 4 deployed instances? We've got the fixed as well as the disconnected, denied, intermittent platforms, and kind of using these containers to basically push everything out. So we have Air Force solution now that is using Harvester as their baseline to implement basically their platforms regardless of which stack it is, so that it's the same, and they can work on creating one set of automation deployments and perfecting that as opposed to rewriting it for each of the environments depending on what that mission stack is. As I mentioned, so today we're primarily focusing on Harvester. So that's the far right one, the RGS virtualization. On the far left is our RGS Kubernetes. So that's if you just need Kubernetes. The right is if you just need the virtualization piece. And then the middle ones are kind of if you need some more capabilities. So the RGS Prime, if you need that basic Kubernetes and the Rancher Manager and observability. And then you have the suite. And the suite is everything together. So if you need the virtualization and you need to run containers and observability, security with NuVector, the suite includes all those things as a single offering. Basically, we do things in CPUs. We don't care how much RAM you have or any of the other components. It's just going to be based on the CPU cores. So, and basically we use that one Rancher manager to manage them all. As I said, as long as you're on that connected interface, if they share network connectivity, you can have them all managed by a single rancher and then use your RBAC controls to restrict users to whichever ones they need. So maybe some users only need cloud, or maybe a subset of that cloud. Others need the data centers or just a project within there. You can use RBAC, and then the admins or the security team kind of keep an eye on everything all at once. Pull four real quick. Basically, what their familiarity with Kubernetes is. This is basically what Harvester looks like. Once you install Harvester, as I mentioned, it's basically an ISO. This particular run is just running on a NUC sitting on my desk over here. You just go through the install process, get it up and running. It's going to basically bring you to this once you log in for that first time. And so you're going to get this nice overview of what's going on. You can see how many hosts make up this cluster. In my particular case, it's just a single one. But you can see how many virtual machines, any virtual machine networks that you've created that are available. And again, this is going to depend on your RBAC, which we'll get into in a second. So one of the things to note is, so with Harvester, you can get into this and everything, and you can do everything just from the single interface, but you can't do any RBAC additional users or anything like that with just the Harvester. So you need the Rancher piece. So that's why it comes with Rancher as part of the bundle for managing it. And once you install that, so whether you install it on that Harvester cluster or you hook up a Harvester cluster to an existing Rancher cluster, then you're going to have your Rancher. And down here you have this virtualization management, which shows you your Harvester clusters. And we can get back to that same thing, basically that same interface. And this is where you can create the additional users. You can tie into various authentication providers. So we have a variety of them built in. The majority of the ones that you're likely using should already be here, and you can find examples as well for how to configure these. But basically, you can set these up and then limit your users. You can say, all right, what types of roles? We have a bunch that are already built in. If you need one that's more customized or whatever, you can always create new roles. You can create global wide ones. You can create cluster specific ones, or even project namespace specific ones. And you can basically use all of that to customize what your users have access to and restrict what they're able to see. So if, for example, I had, let's say, three clusters here, but I only needed access to one, I'd only see the one, even though there may be some other additional ones here. Whereas your cluster admins, maybe they need to have access to them all. Same with, usually security has like a read-only view to all of them, so they can look at your status and basically set everything up that way so that you can have this nice single pane of glass and go across all of your environments. So let's see what it looks like. So we do have this one host. We've got a couple of virtual machines I've created here. And then, so this particular Rancher instance is actually running on the RKE. It's an RKE2, but I was debating on creating multiple RKEs, so I named it one so I could do 2, 3, 4 if needed. But I can go ahead and pull that up in basically a tab. And that's, of course, not the screen I'm sharing. I can pop that up. You can see I just installed Ubuntu as my image here. I can interact with it just like you can with any other interface. I could SSH to it. So what I did in my particular environment is I have this, like I mentioned, it's just a small little NUC. It's got 8 cores and 64 gigs of RAM, but it also has two NICs. And so one of the things I did is I used the one NIC for using the Rancher interface, doing in the management and all those types of activities. And the other one I set up as a virtual machine network, and I just put all my VMs directly onto that network. I could, if I had set up VLANs, I could set it to use particular VLAN or VLANs. But in this particular case, I just dumped them all out onto my network so I could directly connect to them if I wanted, and I can SSH, and that's how I did a lot of the configurations here, so I could basically use some scripts to deploy this because you can't really copy and paste into the browser as view here. But you can see everything. It's just it's pretty responsive. It's your normal interface. You can get into that. So let's go back to
So while you're working on that, we had a question on nested virtualization for testing
yeah.
environments.
Officially, it's not supported, but it does work. The main thing, of course, to keep in mind is the virtualization, of course, is going to give you slower performance. So as long as you're aware and you're not trying to do any testing, like performance testing between the environments, then it'll work. Everything will be fine. Just you don't want to try to do any performance because your performance is obviously going to be degraded from those nested virtualizations. You're gonna have your multiple VMs. So again, just because this is a Kubernetes environment, so we can go ahead and put things in particular namespaces. So if I switch to a different namespace, you wouldn't see all of them. So we can see if I switch to default, there's no namespaces here. So if I didn't have permissions in my RBAC to look at the VM's namespace, which is where I put them in my local environment here, then you wouldn't be able to see them. So you can use that as well to basically isolate your networks, your storage, all the different components you may need, and the VMs to particular users or subsets of users. So you can give the different teams different environments, and they wouldn't be able to see or mess with anyone else's environment. If we wanted to create a VM, so we'd pick which namespace we want it to be in. If there's not one that we want there, we can do a new namespace. We can say whether we want multiple copies of it or a single instance. We give it a name, test one. We give it the number of resources we want to give it, how much RAM we want to give it. If we had loaded an SSH key, so we could also create one, we could load that in so that it gets added to the VM automatically. For volume, so one of the things is you can upload all these images so that things are kind of nice and ready for you to go. You can also create templates. In my case, I've uploaded a couple ones. So I've uploaded this cloud image, this live one, and this Windows one. And I can just pick one of those as my default volume. It detects that it's an image, so it's switched the type to CD-ROM, set it to the size it needed to do it. And then I can just go ahead and add my new data disk. And I can change the boot order as well. So let's say if I want to have that first so that I don't necessarily have to eject the disk after the fact, I can go ahead and set that up. And then what your VM is going to do, just like your PC or any other machine, it's going to see there's nothing there on disk one. So it's going to go to the next thing in the boot order, which in this case is our CD. So that way it boots that up onto that. And I don't have to make sure that I eject the disk after the fact. I can take my time, get rid of it later. Maybe I want to leave it to load some additional tools or drivers, but it's not going to keep trying to boot off that same machine. As I mentioned, you can set up different networks. So by default, mine's going to this management network, but I had created this VM network that I mentioned, and this VM network is used in a separate NIC just for my virtual machines and dropping it straight onto my home network. I can choose what type of driver I want to use for that network interface. I can choose, so if I had multiple ones selected, I could choose whether I want NAT, bridge, things like that. In this particular case, I set it up when I created the VM network that I wanted it to be a bridge straight out to that machine. I can add multiple networks. So if I wanted, I could have one there as well as one on the management network. That might be in handy. For example, if I wanted this to talk to my machines, so I could SSH to and everything, but I also wanted it to talk to containers more easily. And so I wanted to use that internal Kubernetes network. In that case, my management network might be a better fit so that it can talk to those containers more directly. So you can set your node scheduling. As I mentioned, this is just a single node. So there's not going to be any live migration I can do in this particular setup because I don't have more than one node to migrate things to. And then that's also going to come into if I want to do scheduling. If I want to tell it to run on a specific node, that's going to limit your live migration, but maybe that's my only one that has that particular network or a specific GPU or sensor. I can lock it down and just keep in mind that that may restrict what capabilities are available to it. Um, you can use node selectors just like if you've done any Kubernetes with your containers. So you can use those node selectors to say this should run on this type of node or this subset of nodes. So you can have production node. You can have basically create any sort of label that you want. You can say this is production or this is team A's nodes or these are the GPU AI nodes, and look for those specific node selectors. You can set up any scheduling you need to do. If you need to add labels to this so that you can find it easier later, you can say, hey, this is an AI VM, this is Team A's VM, and then any advanced options. So, for example, the rerun strategy. So, as I mentioned earlier, one of the things that we had to do for a particular government customer is make sure that Harvester could come up and running within 10 minutes from a power failure with no intervention. And one of the things as well is if Harvester comes up but none of the VMs do, that doesn't really do you any good. So you can tell it that you always want it to run, you want it to rerun if it had failed, or you want it to just stop if something happens and it shuts down. You can pick different ones. This one it did detect it was correctly. It was an Ubuntu image. I can tell it what I want to do if I go into maintenance. So if I had more than one node, if I wanted it to go ahead and migrate to one of those other nodes, if I wanted to just shut down, or what it is I want to do based on the preferences for this thing. Any cloud configurations. So this particular one, it's telling it go ahead and install the guest agents and then enable that with a systemctl command. And then if you want to reserve any particular amount of memory, let's say this thing has an upper ceiling of 8 gigs of RAM, but you know it needs at least 4 or things aren't going to work right, you can go ahead and set that to 4. All right, so we got a couple questions. Does this support encryption at rest via Longhorn? It does. You can go ahead and use that encryption in Longhorn if you so want. So, if you look in the Longhorn documentation on how to set that up, it's the same thing for here. And then we have another question in the same boat as nested virtualization. Currently, there's no Packer plugin for Harvester. They use Packer to generate golden images for distribution. The workaround he's found is to use KVM, virtualize it on a host. Are we looking to create a Packer plugin? I'm not sure. I know I've heard people talk about Packer, but I don't know if that was basically creating a tool that does a similar capability or a plugin for Packer itself. We'll have to look that up. So Dustin may be able to find it while we're answering. Otherwise, we'll get you an answer after the webinar. If I wanted to use a template, if I had created one, I could use that. There are some built-in ones that it comes with, so you can use these kind of as starting blocks to jump off from. So you can say, hey, this is a ISO image, this is a raw image, Windows ISO or image. And then if you have multiple versions, you can do that as well. So you can, let's say you have a version, you want to test things out. And so you create a new version that's whatever your test version. You can use that and kind of let certain people have access to it. Again, it's going to use that same RBAC. So if you put that in a particular namespace or something, you can, or a particular cluster, let's say this is only going to be in your test cluster, your development cluster, then you can kind of restrict those things and allow people to test them out there before you roll it out to production. All right. Can this integrate with Foreman as a compute resource provider? Are there any plans to add support for this? I don't know. I have not used Foreman. Yeah, my virtual machines, I got so as I mentioned, we got different networks we can create. So if we wanted to look at my network config, oops, wrong one. So if I want to look at the network config, same thing as kind of like your virtual machines. So you can set this network config to apply to only all nodes, a specific node, or a subset of nodes. So you can use the matching rules, looking for a particular label or labels, say everything, and then you can choose. So as I mentioned, I have a secondary NIC, and you can say what you want it to be, whether you want it to use a VLAN, active backup, balanced round robin, balanced XOR. Basically, you have a couple different modes, and then if you need to set a particular MTU, so example, for as I mentioned, probably for production networks, you want to use 10 gig Ethernet links. So you're probably going to want to use a higher MTU than the 1500 standard that's on a lot of devices. So you may want to set this to whatever that jumbo frame size that your network supports. So I can also drill into that and I can see what it's currently connected to. Um, I can see which virtual machines are using it. I can look at any statistics on the storage that have been set up. So I haven't set up KSM. But if I had set up KSM tuned, I could look at basically what's going on the network there. I can see the different settings on it from a nice high level perspective. As I mentioned, this is all configurable with your RBAC, so you can restrict who's able to see this, who's able to configure it, modify it, so that you can have full control over all your networks and your virtual machines. Just like the other things, we can set up snapshots, backup and restores. So on this particular one, for example, I had gone ahead and taken a snapshot before I did new vector, so I could restore it as a new one. I could replace the existing one, and basically all that did was it allowed me to basically make sure that if I screwed something up when I was setting up the install of new vector, that I could roll back and make any changes I needed and not have to do it just like many people use snapshots for all the time. So I had made a typo the first time. So then when I blew it away and did it over again, I made the same typo and then I was able to revert. And the third time was the charm. I was able to get it installed. It's up and running just fine. And so New Vector, as I mentioned, is our security tool. This basically just gives me a security overview of my cluster. So my cluster doesn't have anything too exciting because I'm the only user. It's not a very big cluster. It doesn't have a lot of workloads running on it. So there isn't too much in the way of security events on it at the moment. That's more on the Kubernetes side, whereas on the harvester side, so we can do monitoring and logging. As I mentioned, we can set up our RBAC. We can say who's allowed to view what, make any changes, configurations. Under the advanced, I mentioned templates. So you can go ahead and create templates. You can create new versions of the templates. You can make modifications. Okay, so it looks like Bradley found there is a foreman for KubeVirt, so potential there. We can double check if you want still if it's something that's officially supported or if we can add it as a officially supported functionality if it's not already.
Yeah, I put in the answer on the last one that would probably, from what I can find right now, it would probably need to be an RFE, request for enhancement, for paying customers or a GitLab issue or GitHub issue.
Okay. Yeah, so looks like the capability is there. So if you're an existing customer, we can put in like you said, an enhancement request and get that prioritized. Or if you're just interested and want to have it potentially in there, you can open up a GitHub issue on the Harvester project and see if it'll get through the community and get in there eventually as well that way. If we add it as an RFE, that does make it its back way into the community version, so it's not something that's gonna be locked away only for the paying customers. So we do all of our development and commit it back to the upstream as well. As I mentioned earlier, so I hadn't set up any SSH keys. If I did, again, you can put them in particular namespaces. You can create a new namespace, but you can put in those SSH keys. And so you can use that to set up your VMs, things like that for the community of users without having to set up the credentials potentially for them to have username password to log into those machines. Any cloud templates that you want to create and use. So as I mentioned, this is just a simple little NUC, so I don't have anything particularly fancy to hook up. But if I did, I could do my PCI devices. So frequently, what I've seen, these tend to be sensors of some sort or radios for communicating to either aircraft or satellites or or weather balloons. And you can use then pass those through either to virtual machines or to containers. Same with vGPUs, so you can install the NVIDIA operator and the NVIDIA toolkit. And basically, once you have that, then you can slice up those NVIDIA GPUs and kind of pass them on to the various virtual machines as needed. And you can see here's basically where it was mentioning, hey, I didn't have all these different add-ons turned on. And so that's where that was coming from, is it if I wanted to, I could go ahead and enable them. The only one I have deployed in this particular environment is Rancher Monitoring, but you can create other ones as well and enable them if you need them. But if you don't, might as well leave them off so you save the resources. Any secrets that you may need to set up? Again, same as Kubernetes if you're familiar with Kubernetes. So you can use secrets to store credentials, configurations, things that you want to restrict. And using that RBAC, you can restrict who has access to them. So you can say that this application, for example, has access to it, but only the admin users have access to it, so that you can do those configuration changes without requiring everyone to be able to see it all the time. In the settings, we can go through and set up all kinds of settings. We can set up duplication, logging. So someone earlier mentioned storage. So we use Longhorn as the storage for the HCI. And so one of the things you want to keep in mind is you don't want to use Longhorn with a storage appliance. Because, for example, if you have a NetApp, your NetApp's going to want to make 3 copies of everything for redundancy. Longhorn is basically a software-defined version of that. So it's going to want to make 3 copies of everything. So if you have Longhorn and a NetApp appliance, you're going to end up with 9 copies of everything. But it is Kubernetes, so we could, for example, have our Longhorn storage for any local disks and doing software-defined basically storage there. But then we can have it go ahead and connect it to using those CSI providers like any other Kubernetes cluster. We can use the NetApp CSI provider to connect that up as an additional storage class. And we can again use our RBAC controls to say, hey, these users are allowed to use the NetApps, these are allowed to use Longhorn, and people frequently do that for basically different types of storage classes. What's the difference between those four? Oh, so the difference in these that basically these are just kind of built out of the box. In my case, they're always going to be unhappy because I didn't change the configuration to make it from 3 replicas to 1 replica. It's always going to try to make 3, but I only have 1 node, so it can't do that. The Harvester Longhorn is kind of fine-tuned for doing those Harvester workloads. So that's the main thing for that, and that's why that's the default. So when you create VMs, it's had some settings applied to it that are basically optimized for Harvester workloads. I don't remember what the difference between the other two is, but just like with Kubernetes, you can only have one default. Usually people will either set that to the one that's the easiest and simplest to use or the one that's the cheapest. So that way, by default, it'll go to the slower, cheaper storage. And then if people need something faster or specialized, they either need to have the access granted or they have to manually select it so that not everyone's using your super premium NVMe flash array, for example. Yeah, so that's what a harvester looks like, and harvester with the Rancher dashboard. Kind of gone through the overall products as well as focusing deeply on the harvester piece. So this is where you have extensions. I don't have any repositories added, but you can do that. Might be where you would do the foreman without having used foreman. I couldn't say sure, but I would guess you might be able to add a repository for the extension and do foreman that way. Fleet is kind of cool if you've not used Fleet. So Fleet is a continuous delivery tool. So this is really key for doing your infrastructure as code. So you can go ahead and make a application, and then you can say, I want it to deploy basically to all. So there's default Fleet and Fleet local. So Fleet local is going to be the one the rancher's installed on, which in my case is the only cluster. But if you had a whole bunch, you'd set it up so that anytime a new production cluster comes up, for example, you want this application to go ahead and be deployed across it. And you can use Fleet to do that so that you don't have to come in here, stand up your new cluster, and then say, go ahead and create me another cluster. It'll deploy this application on said cluster once it comes up. It's just going to monitor for the clusters that match its definitions, and then it's going to go ahead and deploy that. And so in this particular case, it's just a really simple app. So if we look on this, it's just made this little rodeo thing. And basically all it's going to do is it's pointing at this Git repo. And I'm telling it basically do these black cows and do a couple of them at a time. if I go in here and I go back down to my fleet and go into my demo, and if I edit the config, and if I change it from the main branch, let's say I was doing some testing, I have this red branch, go ahead and save it, and you can see it already detected this difference, so it's going to go ahead and roll that out. And then once everything's ready, now it's ready again. If we switch back over to this, you can see it's already started rolling out these red cows instead of these black cows. And so you can do that obviously with much more than a simple little dumb cow application to just sense things up. But if you had some real application that you needed across all your clusters or a subset of those clusters, you can use Fleet to kind of automate that and do that continuous delivery of your applications so that they're always ready for your users. And then you can use that GitHub, you can use the change log to keep track of when those applications are changed, who made those changes, who approved those changes, and then roll them out to all of your clusters. And if anything happens, you can roll back your Git versions. In my case, I can go back and switch back to the main branch, whatever it is I may need. Can Harvester do VM auto-scaling master images for VDI use to child clones similar to VMware vCenter with Horizon VDI? So for VDI, what we do, I mentioned earlier, we have this partnership with Chasm. So Chasm does our VDIs. What the Chasm is a Kubernetes native, basically VDI tool, and that tool allows you to do those scaling of those images automatically and scale them out for your VDI use cases. And as I mentioned, the other thing it can do as well is particular applications. So if you go out to the Chasm website and play with their application, their samples, for example, they have a Doom application that you can do. And all it is, it's not a whole VM, it's just the Doom application. They also, of course, have Chrome, they have some other things as well. And they have like a Fedora VM. So you can kind of really scale that as needed for your users. So maybe they need that whole VM to scale out, but maybe they only need a browser or Visual Studio Code, or some other particular application, and you can give them a much smaller footprint, which would enable you to either run more applications on that same server or run less servers. Packer question, not on the road, if not on the roadmap, is there an alternative suggested approach for configuring and managing your VM OS images? Yes. We use something called Elemental for basically managing those images. That may not play into every use case. I know Dustin looked at the up the Packer question earlier. Dustin, was Packer on the roadmap or supported, or is that one we're gonna have to get back to them on?
Yeah, Brian Durden on our team has a deployment with Packer for some RKE images for automation. It had
Okay,
utilized in the past, but it is not currently on the roadmap as that is a HashiCorp product.
gotcha. So it has sounds like it has worked. We do have one of our engineers that has some code out on GitHub that has done it in the past, but it is not something that we currently officially support as it's a third-party product with Hashi. But it has been used successfully in the past, so hopefully that helps. I saw there was one about Chasm
Yeah,
posted.
it was just more of use and authorization. So the best
Okay.
way is to reach out to the Chasm team. And if
Okay.
you can't get a hold of them, you can get a hold of us. We can help you get in touch with them for deployment. They are deployed in the DoD and IC. So just reach out to them for more information.
We do have a very close connection with them. They are in our Slack channel. They can message us and we can message them. So they are very responsive. But if you're unable to get a hold of them, feel free to reach out to us and we can reach out to the Chasm team and help you get those answers. And we thank you for attending. If you have any questions, feel free to reach out. Thank you all for coming.